Hey, welcome to obd2. Okay, obd2 shares a lot of components across platforms. You know, all cars have EGR? No. A lot of times that's not on a lot of cars. All cars have EVAP systems. Well, if it's gasoline powered and it is after like 1965 or so, yeah, it probably has one. All cars have an intake air temperature sensor. Well, most all new cars do. All cars have a MAF sensor, mass airflow. No, not all of them. You know, but a lot of them share the same types of components. I mean, not all cars have a MAF, but all cars that do kind of work almost the same. You know, all cars have an EGR. No, that's not true, but if a car has an EGR, it works about the same as the rest of the cars with an EGR. Get it? I mean, there's some global sharing, but not all cars have every single system. We get into system hardware. You know, EGR, they're all do basically the same thing. Fuel injection, there's different types of fuel injection. Now we have direct injection. In the past, we've had central fuel injection, or you know, all of these things come into play. Now, we've had evap systems, evaporative emission systems, for years and years. You know, but now we have what's called an enhanced evap system that has to check for leaks. Whereas in the past, they didn't do that. It was just assumed that it worked. And if it didn't, nobody said nothing. Anyways, so almost all cars have O2 sensors or wideband O2 sensors, one of the two. We'll cover the differences later, but just realize that they're numbered. And you know, if we look at a scan tool, bank 1, sensor 1 is going to be pre-cat on the number 1 cylinder side. How do we decide which one is the number 1 cylinder? Well, on an inline engine, it's usually pretty easy. It's the one that's closest to the front or accessory drive of the engine. When we start talking about a V-type engine, is there an easy way to tell which side number 1 is? Yeah. We generally look at the spark plug itself, and you know, if we have, you know, a V-type engine, there's one on each side. Number 1 cylinder is going to be the one that's furthest forward. Get it? Towards the accessory drive. We okay? And just remember, you know, bank 1 is going to be on the number 1 plug side, or number 1 cylinder side. Bank 2 is going to be the other side on a V-type engine. Sensor 1 is going to be pre-cat. Sensor 2 is going to be after the cat. So if we're looking at a scan tool and I got a code for O2 sensor, bank 1, sensor 2, I have to know which side, which one that is. I mean, some cars have 4, some cars have 6, some cars have 3. You know, if I have a code for it, I need to make certain that I'm getting the right one, which can be problematic. I've seen people change O2 sensors and change the wrong one. Get it? Make sure you know which one it is. And then we start running into this, you know, PCM is the powertrain control module. Is that in charge of trans function? Sometimes there's a separate trans controller. You know, is it in charge of cruise control? Is that built into engine function? It may not be. Some things that are surprisingly built into the, PCM is charging. Alternator control is a part of the PCM. And we'll talk about why that is, and it has to be when we get to like misfires and talk about that. All right, nuts and bolts stuff. We got inputs. which is, sensors generally. And then we got outputs, controlled devices. What are we talking about? Well, evap solenoids, injectors, that's an output controlled. A coil for a cylinder, output controlled. The solenoid that operates variable valve timing, that's an output. What's an input? Well, sensors, throttle position sensor, MAF sensor, that kind of stuff. Then we have what happens inside the PCM. PCM is designed, to take these inputs and put it into controlled outputs. But there's stuff that happens inside that box, a thought process, if that makes any sense. Anyways, we get into these diagnostic tests, which this is where we get our DTCs from. Diagnostic tests generally go into one of three categories. There's a passive test, an active test, and an intrusive test. Passive test is just watching what the car is doing, what the sensors are telling the computer what the car is doing while it's generally driving around. I mean, you think about it. Okay, so I push down on the gas pedal. Throttle position, computer sees a change in voltage on the throttle position sensor. And then it sees an increase in engine RPM. Get it? And it sees an increase in mass airflow coming in, and it sees a corresponding change in MAP, manifold absolute pressure. Those things all make sense. Okay, but let's say the throttle position sensor goes bad. So it doesn't know you push down on the gas pedal, but it sees MAF change and MAP change, but not TPS. Well, that's a problem. Get it? So it may go into some active testing, to try to decide, well, is the throttle position sensor bad? We're pretty sure it is. Get it? We can also go into these more drastic tests. They're called intrusive tests. And this may affect performance or emissions, and the customer may notice this. So let's say it kicks up the idle. Okay? And let's say it has a problem. It sees TPS, it sees MAF, but MAP isn't acting right. It sees a problem with MAF or MAP. Okay? But, so I crack open it cracks open the throttle, or it increases idle. It sees an increase in MAF, but doesn't see an increase in MAP. Well, that's deemed as being the problem. Get it? And the customer may notice, they're driving along, and all of a sudden the idle kicks up while they're sitting there at a light, all of a sudden, oh. And then check engine light comes on, But it may have been observing this thing for a while now, making certain that sensor is bad. Get it? People think, the car glitched for a second and then the check engine light came on, so that's when it blew the code. No, it had already run maybe 4 or 5 or 6 tests in the background that you didn't notice. Watching, maybe doing some stuff that you didn't notice, and then bang, all of a sudden the check engine light comes on. Check engine light came on because it was certain that was the problem. It may have been watching that particular thing for a while. O2 sensors or, coolant temperature sensors. Remind me to tell you the story about the coolant temperature sensors when we get to class. I'll tell you that story. Anyways. All right, a couple other key terms we got to know. Warmup cycle. Warmup cycle generally is instituted by key turned to on, and it's a 40-degree rise in coolant temperature and hitting at least 160 degrees Fahrenheit. Now, this is used to clear DTCs. Get it? We clear DTCs by counting the amount of warm-up cycles. Anyways. Trip. A trip is generally a key cycle on, and then some test has met its enabled criteria, which means the criteria it uses to run the test, to run. Okay, so it charts the result, and then it powers down. That's trip. All it has to do is pass one test, which happens all the time. Now, it learns from previous tests, and then we have different trips that do different things for different DTCs. It may not all be in the same test. As a matter of fact, it would be very difficult, and we'll talk about this coming up, to run all of the tests in one trip, because a lot of tests need a cool down and then a warm up again. It's a 2-trip diagnostic. Get it? And then some of these things are blocking of other ones. Here, pick out O2 sensors again. O2 sensors required to test the catalytic converter. So before the computer can test the catalytic converter, it has to make sure that the O2 sensors are good. Get it? No. Conditions to set or conditions to run. Cadillac had a slightly different nomenclature for this, but everybody uses the same thing. And so not all tests are run every time. Some tests have authority. Okay, what do I mean by authority? Well, stuff that's really important, like number one sensor that's used, that probably has the highest authority of anything, probably coolant temperature sensor, okay, and like throttle position sensor. Those are in charge of a lot of fuel. We okay? All right. And then all DTCs have different criterias to run the test, but they also have different criterias to set the code. Get it? So we got a criteria to set, to run, right? And then we got another criteria that what it takes to set the code. Get it? Get it? Get it? Get it? And then other sensors are involved. So we can have blocking codes. Like, let's say the O2 sensor has gone bad. Well, that is required to run the catalyst test. It needs a good functioning O2 sensor. So the computer is going to say, oh, the O2 sensor isn't any good, so that means it's not going to run the catalyst test. Why? Well, it doesn't have the sensor to do it. But then all you got is the O2 sensor code. So you fix the O2 sensor code, and then guess what happens? The computer goes, hey, I got a good O2 sensor. Let's run that cat test. And all of a sudden, you put in an O2 sensor, fix the code, ship it on its way, bam, comes up with a cat code. Well, why did you come up with that? Well, because now it had a good one to go test the cat, and you screwed up. Get it? When you do this, you should go check and see what monitors haven't run, so you can make sure they run before the car leaves, so you know there isn't a blocking code happening. Now, this is also why we don't clear codes, because if we clear codes, what happens? It wipes all the monitors and set them all to non-complete. So this is hundreds or maybe thousands of tests that live under all these monitors that need to be run before it can run other tests, and this is where the diagnostic strategy starts coming in. It would be like me taking your phone and resetting it to factory, okay? Because that's exactly what you're doing. You wipe out all your pictures, all your Snappies, all your TikToks, all your, I'm dating myself, all your Facebook, I don't know. It deletes everything, changes it back into a factory phone. How pissed would you be? It's the same thing that the car computer goes through. It's going to be pissed. Okay? All right. So here, look. This is how it kind of works. We got key on. Oopsie. We got key on. Enable criteria is met or it's not met. If it's met, it reports it as a run, records the results, tells the diagnostic executive, key off and power down. If it's not met, well, it still records these results as not being met, still tells the diagnostic executive that, hey, I didn't get to these tests, we'll run them next time. It's like putting them on a schedule then, anyways.